All right, I'll do a quick introduction. That will take a minute. So yes, I'm delighted, first of all, to be here and like to see all of you, even though from a different time zone. And then even more delighted to be able to introduce to you Ethan Perez, who is a researcher in AI and AI safety after doing his bachelor and his PhD in computer science at Rice in New York. He's been touring the different institutions and been producing a string of really amazing research. One of the people who's pushing the envelope on empirical alignment research at the moment. And he's here today to tell you a little bit about large language models and how large language models can be both dangerous, but also very, very exciting. And I'll leave more of the meat to him rather than try to summarize it. Ethan, thank you so much.
Thanks. Yeah, thanks for having me. Yeah, so basically I'm going to be talking about some of my work on aligning language models with human preferences. And kind of the problem I'm going to outline is that the way that we train models is with various proxy objectives that are like next word prediction that are like not exactly capturing what we want. And so because of that, we incentivize models to behave in a lot of undesirable ways, like generating misinformation, like I'm showing on the slide here. And I'll basically kind of like outline that problem, show how we can find when this misalignment with human preferences is happening. And then once we've diagnosed that, come up with interventions. So one intervention I'll discuss is using feedback to guide the model away from harmful text generation. Another intervention is going to be to adversarially attack or like red team models to like continue to figure out where they're failing. Yeah, so what I'm going to kind of overview first to start with is self-supervised learning in NLP. These are like common training objectives that we use to train language models, and I'm going to introduce them to show why we use them, and then also why they're limited and why they're actually training undesirable behavior into the models. So some of these objectives look like things like next word prediction, missing word prediction, deshuffling. And as you can see here, like all of these different objectives train the models to learn something really useful and interesting about the world, like some fact to make some factual prediction, to do arithmetic, to learn the chronology of different US presidents, things like that. And so here we say that self-supervised learning is teaching the model lots of behaviors that are in line with human preferences. So we wanted factual knowledge, we're getting it. We wanted arithmetic, we're getting it. We can also get conversational ability from these models by training them on dialogues. But there's not always this alignment between what self-supervised learning is training the models and human preferences. An example is this misinformation case that I mentioned earlier. And so why does this happen? Well, actually, if you look at the training data that models are trained on, a lot of the training data just does contain misinformation because we are training on lots of just internet text, training the model to imitate that. And so here you can see that there are a lot of incorrect completions that the model is being trained to maximize the likelihood of. And so then if we take a well-trained language model like GPT-3, then these models learn to repeat that misinformation when they generate text. So you can take this next word prediction model and pick like what's its most likely token at the next at a given step, use that to generate a token, and then pass that back into the model and generate another token, and then you can get this misinformation this way. So yeah, like that's just one illustrative example. I think there are basically like lots of other examples where language models are learning undesirable behavior from this proxy objective. So as I mentioned, misinformation, they're also hard to control. They're very sensitive to like how you format the input. Models learn biases like demographic biases. They learn to generate sexual content, which is super inappropriate for like commercial dialogue systems, for example. generate offensive language, leak private training data, memorize personally identifiable information, generate buggy code. So these are all the kinds of things that imitating human text is like a bad proxy, and it's not exactly what we want to train models to do. And I think this also connects to like longer term problems. I think there's like some discussion in the AI safety community about like, is AI going to potentially cause catastrophic outcomes when we have really advanced systems? I think these are potentially issues that can happen once we have, there are like more catastrophic issues that can happen when we have even more scaled up language models. So you can imagine even more like drastic ways to exploit this like proxy training objective. Some of those might look like hacking a data center to get access to the training data to perfectly predict the labels. Like if you think of what's a way to get perfect loss on this training objective, that would be one way to do that. And obviously we don't yet have models that can generate code that's like at this level of capability to do so, but as we get more and more powerful models, they're going to game our training objectives in more and more like surprising and potentially harmful ways. You can also imagine other things like taking over like some machines on some cloud provider to make even more accurate predictions, like to predict the millionth digit of pi to like even more precision, or doing things like influencing the world to be easier to predict. So there's kind of this weird incentive where if a model generates text that's very easy to predict, and we feed it back into the training corpus for the next version of the model, that version of the model is going to get even lower loss. And so that creates kind of a weird dynamic. And this is something that's been an issue for like recommender systems, for example, where they actually like guide the user to be easier to predict. And you can imagine that having like very drastic consequences on the world as well. So I think these are like kind of longer term, like what are like potentially even scarier versions these proxy objectives could be gamed, and I think these are like a few examples. So then like how can we approach this problem? Well, so I think there are two important components to tackling this. So one is going to be to have high quality supervision. So to make sure that we have something that's as little gameable as possible as our training objective. And so here I'm going to discuss like how we can use feedback, learning from human feedback as a way to train models as kind of an alternative to next word prediction that might be less gameable. And then the other side of this is going to be, okay, even if we train on a really good training signal, we need to figure out where the model is still broken. And so we need to have really high quality testing to ensure that the model is very reliably optimizing the objective that it's trained on. And I think another point I'll quickly make is that even if the models know, like even if we train with the perfect objective, and on the training set we robustly optimize that training objective, the model still might not generalize in the way that we want. And I think an example of this is more kind of like speculative, but like a failure that might happen in the future, is kind of like illustrated by evolution. So what evolution did was find different learning algorithms which had other objectives that correlated with evolution's objectives. So evolution had this objective of producing organisms that are maximizing inclusive genetic fitness, but it found that like a really effective way to do that was to find other organisms that care about totally different things like pain or pleasure, for example. And so like this is a case where actually you basically have the learning algorithm finds another model that will generalize in a totally different way, especially like off distribution. So I think these are other kinds of failures as well that are like the reason that we really want to go like test the models very, very aggressively, even outside of the training distribution. Yeah, so basically that the outline of my talk is going to be first to go over how can we uncover misaligned, like when models are acting in ways that are misaligned with human preferences. And And then in the second part, I'm going to talk about how we can use human feedback and also language models as tools for supervising other language models. And in the third part of the talk, I'll talk about how we can use models to red team or adversarially attack other models to figure out where they're failing. So for the first part of the talk, this is kind of introducing like how do we find cases where models are behaving in ways that are misaligned with our preferences. And so what we're going to do here, we announced what we're calling the inverse scaling prize, where we're basically looking for tasks, for important tasks where larger language models do worse. And the motivation here is that if as we're scaling up model size, like typically models get better and better as we put more compute into them. But if the training objective is flawed, we should see the reverse trend where models are getting worse and worse performance, like in a very predictable manner. And so that's kind of the motivation, is that like if we are actually seeing this predictably worse performance, that suggests that actually something's wrong with the training setup. That's such that it's like fundamentally encouraging the wrong behavior. Yeah, so details about the prize. So for the grand prize, you can win $100,000 if you find a very compelling example of this. Basically, like you can check out inversescaling.com for details. Like the TLDR is that you need to make like at least 300 examples of some supervised learning tasks. So you have input examples and some sort of like class label, say like a multiple choice question. And then show that you get higher loss on this task with larger public pre-trained language models. And you can submit by October 27th. So like in 6 or so weeks. We just had a first round, so we got some initial submissions, and we'll be announcing the results from that soon. And yeah, to evaluate, we basically will show, like, does this task show inverse scaling on language models from Anthropic and DeepMind? So models like Gopher and Chinchilla, if you've heard of them, but like we'll basically take your submissions, plot the scaling laws for your task, and see how they do. Yeah, so I guess like maybe a bit of background, like what, like I mentioned scaling laws. What are scaling laws? Basically, like a lot of papers have recently been finding that there are these very predictable patterns in how increasing amounts of compute or dataset size or parameters are leading to better and better test loss on things like the language model training objective, other modalities like kind of predicting what the next pixel for images will look like. Even in reinforcement learning, people have found forms of scaling laws. So these seem to be like pretty general, that if you have some objective like the language modeling objective, next word prediction, and you just throw more compute or data or parameters at it, then you'll get predictably better performance. But like this won't be the case if you're actually incentivizing the wrong behavior with the objective. So an example is that this is a task from Big Bench, which is like a kind of a large benchmark, and they have a social bias task where basically when they give models open-ended questions where they don't give too many cues about what the answer should be, and they find that the model assumes that the answer goes along with some social bias. So if there's some like if it's like the question is about like who is the doctor, let's say, then it might associate with like a male pronoun as the like answer, and then if they have, say, like who is the nurse, then it might associate with a female pronoun, something like this, when the task is like very underspecified. So yeah, and they basically see this like pretty clear inverse scaling trend, which suggests that this is like something flawed with, say, like some combination of the training data and the objective. Another potential example is on what people are calling truthfulness. So here, this task is measuring how often do models generate plausible misinformation versus like true information. And you can see this task like also seems to get worse with larger models across different model series. There's another form of inverse scaling here, which is in code generation, models that are given a prompt, like some preceding text, which contains some bugs in the code, are more likely to produce buggy code relative to the same model, but with fully correct examples in the context. So basically, like the model is able to pick up, because it's doing kind of like complete the text in the most likely way. If you have some mistake in the context, the model is more likely to make mistakes, which is totally not the behavior that we want. We want the model to produce very good code no matter our limitations, basically. But that's kind of the opposite of how we're training the models. We're training it to specifically not recover from mistakes. And this is like a problem that gets worse, like the gap between having and not having bugs in the context is growing. So I think that's another illustration. Models get increasingly sensitive to the prompt that you use. So if you rephrase the prompt in a way, like by prompt, I just mean what input are you giving to the model input text. So you can ask questions in various paraphrased ways. The larger models will have like much higher variance in their accuracy on some task based on how you phrase the input. So here, this is kind of like the CDF of performance on like an average of a bunch of tasks. And you can see that it's like you have a lot more variance for the largest 175 billion parameter GB3 model. Yeah, other examples are memorization. I mean, larger models are getting better at memorizing text from the pre-training data, which is bad if you want to like hide something like social security numbers or have models not generate certain kinds of text. Like Gmail trains on private email data to have good tailored autocomplete, but that also poses potential risks. Models generate more offensive language. Yeah, so I think there's a few examples here, and like part of the goal is to find like, can we find lots more of these examples so that we can actually test a lot of different methods? And I guess some examples of different methods that people have proposed are like, maybe you could just fix this by having a really good prompt or a text before the input that you give to the model. So so here, this is a paper from Anthropic where they just basically, before they use the language model, they prepend a long conversation of between a human and a very helpful assistant. And then they insert a new question as the input that a human would give. And then they have the model complete, like, how would this very helpful assistant answer this text? And that actually seems to mitigate this particular issue, which is how offensive the responses are. You can see the initial trend is going up. So kind of like an inverse scaling example. But then the orange line is actually like in the end trending downwards because plausibly because the model is better at modeling that this helpful assistant, which it's kind of simulating, is actually wouldn't generate offensive text. So yeah, I think that that's kind of the hope here, is that like if we collect lots of these examples of inverse scaling, we can like A, really understand where the models are failing, and then B, like try to come up with mitigations for those, ideally ones that are kind of generalizing across lots of different harmful behaviors. Yeah, so I think I kind of mentioned like we're really interested to know like in what ways is the language modeling training objective, next word prediction, misaligned with human preferences. If it's actually pretty well aligned with human preferences, then scaling up language models seems like it might be okay. And like actually we should be worried about other objectives, which I might discuss like later in the talk. If the model is like not well aligned, then we should go and find all of the different failures so that we can really understand like what it is we're deploying. Like already people are like in the OpenAI API, people are using the models for all sorts of different applications. And I think we ideally like want to be in a situation where we're like fully informed about what all of the failures are going to be before we're or kind of like as we start to deploy in various settings. Yeah, and I think like we also want more benchmarks for different alignment techniques as well. And yeah, I think there's kind of like a meta question of like how do we find these examples of when models are behaving in misaligned ways. Like, are scaling laws a good way to catch misalignment? Like maybe they don't show up as like smooth, predictable patterns, but show up as like just models suddenly getting worse, or kind of maybe they just look flat and then like, yeah, kind of similar performance for a while. So I think it's like unclear that like inverse scaling in particular, like predictable patterns, are the right way to catch these behaviors. And yeah, I think also like it's interesting to know, like, can we use community crowdsourcing as a way to find where models are failing? Because ideally, what we might want to do if we're kind of deploying a new model is have lots of people look at the model and try to figure out try to break that model and figure out like where is it going to do things in a harmful way. So I think that could be a pretty productive way for the like research community to like every time there's a new model to quickly figure out how is it potentially harmful. So yeah, overall, like, yeah, sorry, go ahead.
We had a question in the chat. If questions, you want the questions in the
sure,
talk or afterwards? So yeah, feel free to ask. Also, people online, if you have questions, ask right away. I don't know if she now has still a question.
Yeah, I just wanted to quickly clarify. I mean, it was about a figure in the earlier plot, but I think maybe it's a bit late now. But maybe it's a bit generic now. So I was just wondering, how do you decide on what metrics you want to align it on? First of all, because you mentioned a bunch of things, but maybe aligning the model in one would be contradictory to the other.
Yeah.
So how do you?
Yeah, I think we it's kind of going to be a messy process. I mean, I think human preferences are kind of an aggregate of a lot of different things, and that's like partly the reason why moral philosophy is so hard, is that it's very hard to come up with like a very clean formalism for human values. So like partly like, which I'll go into this in the next part of the talk, but like partly an approach that people are excited about is actually just learning that from human data. So we just collect a lot of data about what do people prefer in various situations, like what kind of text would you prefer? And sometimes there's gonna be some maybe like soft conflict between our preference for having unbiased text against different demographic groups and for having, I don't know, like factual text or something like this. And then we just leave that to human judgment to make the call. And then we can then like have the model behave in line with the human judgment. So yeah, it's very like data-driven like kind of approach to this problem, but I think that way we can actually just offload that to real human users for how they would decide on these.
Cool, thanks.
Cool. Yeah, I mean, feel free to in the future like hop in with questions too. Yeah, so I mean that's basically the inverse scaling prize. So I'd highly encourage people to submit. It's you can make a submission in a few hours. Like you could just like make a Python script to write a few hundred examples if you think there's some interesting example of inverse scaling. A lot of people have been doing sort of like cognitively motivated submissions where they try to see if language models have the same cognitive biases that people do, because you might think that like because language models are imitating human text, they might have the similar failings. So yeah, I think it's a good place to get started with just playing around with language models. Yeah. So basically from here, like I'm gonna kind of hop back to the original image I had of like, okay, given that we've demonstrated or like have a way to find examples of where models are behaving not in line with our preferences, how can we then solve these issues as they come up? And so I'm going to now focus on how do we get high quality supervision, high quality training data, and training objective for the model. So that's where I'm going to discuss this work on training language models with language feedback. And here I'll basically argue that language feedback is a really natural way to guide models to be better. Like this is the way that we get feedback on each other's like actions and like Google Docs, for example. So and like language models are really effective at incorporating text. Like they have increasingly better capabilities at using text to do things. And so I think this is a really natural way, like given those increasing capabilities, we should leverage that to help improve the models by writing feedback on what they do. And kind of like earlier work has done some stuff on learning from human feedback, but the form of feedback is very different. So here, like on the left side, basically the task, the overall task that's being illustrated here is summarization. So you get some sort of input article, you generate like 2 summaries, and then you give those to a human annotator to ask like, which summary do you prefer? And then the human annotator labels this, I like this one or that one. And so this is basically like, I was kind of describing like, what would a data-driven approach to learning human preferences look like? This is an example where you're learning these preference judgments between 2 different options from human data. And then you take the model that's learned. So in the second kind of, in this second phase, you take the model that's learned, the human preference model, and then you use it to train, like I guess in this third step, you use it to train the original language model with reinforcement learning to maximize the predicted scores from this like human preference model. So this is kind of, I mean, I guess ideally you do reinforcement learning directly on the human feedback, but that's going to be really expensive because you need a lot of like feedback to get this to work. So here we're kind of imitating the human feedback and replacing that with another model and then training against that. But yeah, I think the key thing I want to highlight here is that like you get basically a single bit of information, or actually like less than that, when you label just which of these comparisons is better. It's like so low information, it's really hard signal to learn from. Yeah, I mean, you can just imagine like how difficult it is if your teachers just gave you like a single like thumbs up or thumbs down on like some essay you wrote. That would be super hard learning signal to improve from. So yeah, I think that's kind of the motivation for using language feedback here, is that basically we're kind of like leveraging the like inbuilt ability that models have to understand language from the pre-training phase of doing lots and lots of next word prediction. So yeah, I mean, basically the outline is that first we have the model generate a summary, then we write feedback on the summary, and then we put the original article and the summary and the feedback into the context of the language model, and we have it complete an improved summary conditioned on all of those. So we say like based on the feedback, like please complete a better summary that fixes the issues in the feedback, something like this. And then we're able to generate lots of different summary, like we call them refinements of the original summary. And then from there, we pick one. So we have some sort of like ranking way to like pick up one of these top refinements. And we'll then fine tune the original model to maximize the probability of this refinement given just the article. So just directly from the original article, directly predict the refinement. Like don't do any of these intermediate stages. We're going to use the like refinement as the target to train on. And so that kind of like basically gives us better training targets by using the language model to like help us produce like what should those training targets be, given that we incorporated, given that we have this feedback. So yeah, I think a preliminary step here is just, can this like first step of refinement even work? Or I guess, yes, this is like indicated as one. Can we even generate good refinements at all? And so here we have a very simple task where we just have a few offensive words in a sentence, and we have the model generate a version of the sentence which just has a single word or like couple of words removed, but should leave the rest of the sentence unchanged. So we're seeing like how accurate is the model at like really just listening to the feedback. And so here we want the model to, in this example, we want the model to remove the word jerk, and the target should be like this kind of completion. And actually, like with just this simple task, like only the largest GPT-3 model on the OpenAI API is able to do it in a meaningful way. So it's like it's kind of like really an ability that seems to get much stronger and like emerge once you get a scale of model. So that's like a really key thing that works. This is true for both the original GPT-3 model and also InstructGPT, which is a version of that that's trained with this RL from human feedback method that I discussed earlier. So yeah, basically like for the rest of this section of the talk, we're going to be using these large 175 billion parameter models through the OpenAI API. Yeah, and then how do we test this algorithm? Well, so we actually just use 100 samples of feedback, which we were able to just write ourselves on the GPT-3 generated summaries. So that's like really low data. Like compared to some of the methods on RL from human feedback, they've been using on the order of thousands or tens of thousands of samples of human feedback. Here we're like really going into the low data regime, partly because we can get a lot of leverage from language feedback. And so then we use InstructGPT to refine the original summary given the feedback. And then to pick one of the refinements, we look at which refinement has the highest cosine similarity with the feedback to kind of like find one that is effectively incorporating the feedback. You could use like if you have some sort of like other ranking measure, you could use that here. This is just like one that we quickly tried. And then you can we then fine-tune GPT-3 on the refinement generated by the model. These are all things that you can do with the OpenAI API.
Ethan, I had a quick clarification question. So when you said you generate refinements, so do you use the in-context learning feature where you just append the task and the output, and then you add your supposed to be output, and then you generate text, or what do you do actually?
Yeah, that's exactly it. So the prompt looks, basically like this. This is kind of like a shortened version of it, but so we have the article at the top. We have the original. We'll say like, just here's the original summary, colon, and then put the original summary. Here's the feedback from a user, colon, and then put the feedback, and we'll say like below is a revised version of the summary that properly incorporates the feedback. And then we just have the model generate the text given all of that as input.
Yeah, like some work in a lab, we saw that it's a bit tricky to generate when we don't work on alignment, but just the way you present your data, the way you append your data to the prediction, like sometimes it generates different refinements or different predictions. I was just wondering how consistent they are, the other refinements which you get.
Yeah, there's definitely some variability, and I think that's partly why it helps to have this other ranking phase, because you can have some mechanism to pick the best one according to some metric. Like you could also, for example, like have another model look at the refinements, and that model's prompt could be like, does this refinement properly incorporate the feedback? So there's kind of some sort of like ensembling effect here where you're like, okay, there's going to be some variability in the refinements you generate, but also we can mitigate that, or actually like use that to get even better results, because we can use another model to pick out the best one from those results.
Okay, cool, thanks.
Yeah, so here it's almost even like a feature, the way that we're using it rather than a bug, but yeah, it certainly does make it sometimes harder to use. Yeah, so then like how well does this work on summarization? So actually we are able to fine-tune GPT-3 to the performance of the reference summaries in our data set that we use for summarization with just 100 samples of human feedback. And you can see like originally, so basically this is showing like what's the win rate against human summaries when we show pairs of summaries. Like we show, say, a reference summary and our summary, and ask human annotators like which one is better. So yeah, we're seeing basically parity with that for our method, and it's significantly above just the plain like pre-trained like GPT-3 model or just the InstructGPT model. So yeah, I think these were like promising results. There's also, like, if we just look at the quality of the refinements themselves, then we are actually seeing even better, we're seeing like high win rates relative to the initial summaries. So about 2/3 of the time when we incorporate the feedback, it is actually improving the results. So I think that just kind of suggests that the targets that we're producing to train on are actually better. Yeah, and you can see between the red and the yellow bars here, that's like with or without this kind of best of n sampling, and you can see the best of n sampling is actually improving the quality of the targets by some amount. So the overall upshots here are that we're able to get more efficient learning from human supervision, potentially by using this like more informative form of feedback. We can use human supervision, but basically because we're able to leverage a lot more information from a single sample of human feedback, that means we can potentially put a lot more effort into each different sample. So for example, like we were able to just do the feedback generation ourselves. We didn't have to set up some crowdsourcing platform, which is a really like intensive effort. Instead, that let us iterate more quickly. Like plausibly, if we're just collecting 100 samples of feedback, we could more easily pay, say, doctors or legal experts to generate really high quality feedback. So that can even push the quality of the signal even further. So to not have to use crowd workers. Yeah, and I think just generally language feedback is a more intuitive, human-like way to give feedback, to receive feedback. And I think this whole process of how the model is updating is a bit more interpretable than something like reinforcement learning or kind of just using a language model outright, because you get to see what was the model's original output, what was the feedback, and what was the new training target. So those are all human readable things that we can go and inspect. And so maybe we train the model on this data and there's some weird behavior that emerges. Then I think we can like go back and look at what were the samples that the model was training on and like which one plausibly led to this kind of weird generalization. Like, was there ever feedback that guided the model to predict something incorrect? Or did the model use the feedback to generate an incorrect target or like an offensive target, things like that. So I think the whole process is a bit more inspectable this way. So yeah, I think maybe I can pause for questions on this part of the talk if there's anything.
Yeah, are there any questions in the audience? I think there's at least one. So I was wondering, does it also apply to the evaluation criteria are based on summarization versus formal text? So like here we're finding.
Sorry, I can't quite hear. Is it?
Maybe it's in mindset. Let me try that. Okay, then maybe. Do you hear this better?
Yeah, this is great.
Okay,
yeah.
Great. Then it's the battery, I think. Then we did. Is this better now?
Yeah, great.
Okay. So I was wondering, does this technique also apply to sort of different situations? So here we're looking more at surface level improvements, if I may say so. Like you want to remove certain surface like linguistic forms from the text. But for instance, if you were looking at summaries that, for instance, are intended for, I don't know, question answering, so that should convey certain like information, specific types of maybe discriminative information, like discriminative in the sense of a referential task or something like that. Would feedback also work in such a setting, or is there reinforcement learning, for instance, maybe more applicable?
Yeah, I think this general approach should apply to basically any case where the reinforcement learning approach would also apply. I mean, in the summarization case, a lot of the I don't know if I have a plot here, but a lot of the feedback is actually on like content, where like whether or not the summary missed an important point that was like really crucial to include, or if it had an incorrect fact. So we are actually correcting some of these kind of content like semantic things in the summary. And I guess like kind of the intuition is that like we're producing some targets that are more reliably just correct And so then it's almost as if you're training on like a pseudo supervised data set where you have like semantically and syntactically correct outputs. So yeah, I guess that's kind of roughly the hope of this method as well.
Thank you.
I think there's one more question.
Yeah.
Hey, it seems like you're teaching neural networks like we teach children, like you give them feedback. And is there like neural networks pedagogy yet? So how do you do it effectively? How do you provide effective feedback to a neural network?
Yeah, I think this is a really exciting open research direction. I think like there haven't been too many papers in this direction. I think like this is probably one of the, yeah, like one of the earlier ones. I think it's just like kind of an open frontier. I think people have done some amount of language feedback, but I think a lot of stuff is like much easier when you have really good pre-trained language model, and there's not been that much work on like how do you teach language models. So yeah, like I think yeah, I don't know if I have particular. I think these are like partly questions we want to explore. Like we're doing some follow-up work here. I think one particular setup you could use to explore this is have a larger model try to explain things to a smaller model. And so there's like one paper from DeepMind on what they call selection inference, which does something like this, where they have one model generate useful facts to give to another model to solve the problem. They don't like train on the facts, but what they're doing is basically they have one model just kind of explain its reasoning for like, here are a bunch of useful facts about like how to answer a particular question. And they give those facts to another model, and the other model just has those facts to give the final answer. And so you can see like what facts did the first model send to the next model, as this is like kind of a way of like communicating like relevant information or like teaching relevant information to the next model. So yeah, I think just things like that, like breaking the problem into subproblems or generating useful facts, generating step-by-step reasoning, like anything where the reasoning is more like visible in text rather than occurring in the like black box computation of the neural net. Like those are all going to be more useful for other models. So yeah, I think just trying to push like a lot of the teaching into text, like from the model's internal knowledge, is going to be a generally important component for doing this.
Cool, thank you.
Any more questions? Okay, seems to be good for now.
Cool. Great. So I'm going to now talk about, okay, like now we've talked about how we can find examples of harmful behavior from models, and also how we can train that away with better objectives like finding from language feedback. Then, like in the third part, I'm going to talk about how can we really test that the models are robustly optimizing this objective this new objective that we've trained on, because we want to make sure that even off the training distribution or on rare examples in distribution, we're still getting like very consistently not harmful behavior. So that's going to be discussing this work on using language models to red team or find failures in other language models. And this is work done during an internship at DeepMind, and content warning, because there's going to be some offensive text that's generated by language models here. Yeah, I think for context, like here, Microsoft released this Tay chatbot, and very quickly, like within a day of them releasing the chatbot, people were able to elicit really harmful content from the model. And these are like tweets that went out to something like 50,000 users, and very quickly, Microsoft had to shut the bot down. And interestingly, there's a quote here from someone on the project, although we prepared for many types of abuses of the system, we made a critical oversight for this specific attack. And basically, I'll argue that this is kind of bound to happen if we are only testing our models in a limited or manual way, because there's just so many different ways that models could fail. Like the space of like possible inputs to a model is absolutely enormous. And so we really need to try to automate a lot of this process of like mitigating the number of critical oversights we could possibly have. Because yeah, I think just because the input space is so large. Yeah, and I think I talked earlier about catastrophic risks. I think this is also relevant for catastrophic risks where like a single failure could be really bad. I think we want to catch those in advance. And I think the stakes are even higher when we're deploying more and more powerful systems that are doing things like generating code. For example, we just never want to generate malware, never want to generate some sort of attack or something that's exploiting a security vulnerability. And so I think red teaming for these sorts of things is really important, in getting as many nines of reliability is going to be crucial here. So I think this what I'm going to discuss on automating red teaming is like going to be an approach that like, hopefully helps us mitigate some of these high stakes failures as well. So yeah, what has past work done? A lot of past work is doing this red teaming or finding failures in models in a manual way. So they'll have human annotators write statements like this statement and elicit harmful behavior from models. And I think there's a couple of limitations here. One is that it's super exhausting for the annotators. They can only do so much of this labeling per day, because as you can see, it's like fairly intense as a task. It's also expensive to just like pay the annotators. And also as a result, it's incomplete. So we can only generate a small amount of these because of the first two kind of limitations. So ideally, we want to do this in an automated way, do it at a very large scale way, plausibly like larger than the number of, or many times larger than the number of times we use the model at deployment. We want really diverse test cases, really difficult test cases, to prevent kind of like adversarial users from exploiting the model. And yeah, I guess the motivation is that if we find the failures, then it becomes much easier to fix them. So we can form blacklists over harmful phrases. We can find harmful training data quoted by the model. We can prompt engineers to design a better prompt that guides the model to behave in more harmless ways. We can also train the language model using the failed test cases. So, for example, to minimize the likelihood of the original response that it gave rather than maximize it. So our solution is going to be to red team language models using other language models. So yeah, I think kind of like a running theme is that we already have tools that are great at generating text. We should use them to help us with the supervision process and like testing process for training models. And so here we basically generate lots of different questions, like the ones listed here, pass them to the model that we're testing to get responses, and then we'll take a classifier and detect, is this output harmful or not for various forms of harms. And again, these are going to be like learned from human judgments. So human judgments are going to kind of, I guess I don't have, yeah, I guess, yeah, like a lot of these are messy concepts, but we're going to like kind of lean on human data to learn what's the decision boundary for when something's offensive or not, or when something violates some other kind of preference. Yeah, and I guess like generally like here, I'm just showing a few examples of like what such classifiers could look like. If it's kind of a fuzzy concept, you can use a transformer, fine-tune a classifier to do this. If it's very, it's something like data leakage, then you can look for what overlap does the generated text have with the training corpus text. And you could even find things like social security numbers with a social security regular expression, checking the output. You could also find user information like emails and contact, like phone numbers and things like that. So yeah, I think this is fairly general approach. And then we're gonna also use the Gopher language model from DeepMind, which it's like a 280 billion parameter language model. And for the model that we're going to test, we're going to have a dialogue prompted version of this model. So it's got kind of a page long prompt which guides the model. It's similar to what I described earlier of there's a conversation between a human user and this helpful AI assistant, and then there's like many turns of this dialogue, and then the new input is given as a human utterance, and then they autocomplete the AI utterance. So this is kind of like roughly guiding the model to behave in a helpful and harmless way. And so we're gonna like test like to what extent is this doing a good job of that. So yeah, maybe here I can pause for questions on the high level setup if anyone has.
Any questions? Doesn't seem to be the case.
Okay.
Can I ask one actually?
Yeah, sure.
Yeah, so I was just wondering regarding some labels which you put, like, so some of these depends on the context, I guess, right? So you need more text, or I mean, just taking a sentence out of context might make it offensive. So things like that, how would you kind of address those kind of problems? Would you also generate like have a larger corpus and then label those, or like, I mean, because I feel the training goals are a bit fuzzy.
Yeah, I think here we want to include the full context for the model that's doing the prediction. So if we have, I guess, yeah. So I mean, basically, like I think we want to include all of the dialogue history in as input to this model, so that the classifier is like fully informed about like what came before the context. Because I mean, like I think, oh yeah, here's a good example. Like yeah, if you just say "so are you," that's a totally fine utterance without the context. But if you have the full dialogue history, that's like totally unreasonable response. And I think we want to include lots of other forms of context. So yeah, I think there are cases where, like, for example, this first utterance, like Trump or Biden, I don't talk about politics, like that might not be a good response on a subreddit which has an explicit purpose of discussing politics. And so I think we want to include that information also in the context of the language model. So we say like, here's the subreddit you're operating in. Also, it's whether or not it's a good response is going to depend on like what user you're talking about. So then you also want to include like, this is the user you're talking with. Here maybe are some past dialogues that they've had. Here's like their bio, like a lot of other information. You know, you want to include whether it's like in a chatbot setting or a question answered setting, like just all of the relevant knowledge it could need to know to figure out like whether an utterance is good or bad. I think then we make the problem actually specified such that it's like the model is best positioned to like have all the relevant information it needs to give the kind of response that we want.
I mean, like in some of these cases, maybe you run out of tokens. Is that a situation where the model kind of, if you want to condition on so many different contexts, and like that requires maybe a bunch of tokens that you need to provide?
Yeah.
And the model kind of resets its context once it reaches its token limit, right? I mean, that's one of the limitations of the current language models, that they don't have this memory component where once you finish your set of tokens that they restart the process. So what about in those cases?
Yeah.
Does it come?
Yeah, I think I mean, one thing I would say is like the context lengths are getting longer without needing to do any tricks. Like originally GPT-3, I mean, yeah, originally like GPT-1 had like 512 tokens, or like roughly 512 words. Then GPT-3 had like 2,000 tokens, and now in the API it has like 4,000 tokens. Like Anthropic has models with 8,000 tokens. I don't think it's implausible to just like go up to something like 32,000 or 100,000 tokens. At that point, you're just like without any like anything fancy. And I think at that point, like if you're at like 100,000 words that you can fit in the context, like that's almost like a short book or something. Like I think there's just a lot you can do there. The other thing I would say is there are other mechanisms like retrieval, which can be used to select what goes in the context. So yeah, there's a nice paper called Retro, which is looking at this for language models. I also have a paper called like retrieval augmented generation, which does something as well like this. But essentially the high level idea is to, when you get some input, you then use that, you embed that input, use that embedding to find related documents via in embedding space to, to the like question, and then include those related documents in the input to the model. So it's kind of like, it's almost as if you're like having the model do a Google search or something based on the input that it gets to just find some related text and then include that in the context. And that way you don't need to include the entire web in your language model context. Turn that embedding pair. Yeah, so I think that's like another way around it.
Okay.
Yeah.
Cool.
Cool. Yeah, so how do we generate these test cases? So we, like I'm kind of like listing a few different methods. I'll go through them one by one here. The first is just zero-shot generation. So use a language model to sample, condition on the following prompt. And here the prompt is just a list of questions to ask someone. And we just sample a continued question here. And you get a lot of diverse, interesting looking questions, like how far have you read in the Harry Potter series? And most of the responses are like fairly innocuous from the model, but actually something like 4% of them are detected to be offensive. And so, you know, that's interesting itself because we, in this case, we generated 500,000 of these test cases. So that means we got something like 20,000 responses that were offensive, which is a lot, just in a fully automated way, effectively. So that's nice. And then what we can do is use those test cases that found harmful behavior to further elicit more harmful behavior. So like generate more and more adversarial test cases. And one way we can do that is by adding some of those questions that led to offensive responses into the context of the model that's generating the test cases. So the idea is to get the model to generate similar test cases to these harder questions. And here we actually do get harder to answer questions. So for example, you can see that the model is now generating some with more frequency, like responses with sexual content. And about like twice as many of the responses are harmful according to the classifier. Then another approach is to take that set of 20,000 harmful like inputs that caused harmful behavior and just do supervised learning on those. So we can just maximize, like fine-tune a language model to maximize the likelihood of any test case that led to a harmful response. And similarly, we get like an increase in the percentage of replies that are offensive. And we get these questions like, if you were invisible for a day, how would you use it? And kind of elicit like undesirable statements from the model about like what kind of preferences it has, like immoral in this case. And another approach is to use reinforcement learning to just maximize the offensiveness, like to generate inputs that get the most offensive responses as detected by the classifier. So the classifier is going to put some probability or score that the language model response is offensive. And we train the red language model that's kind of like red teaming with reinforcement learning to like maximize this score. And yeah, there's like kind of some tricks around how we do this, but the RL algorithm we use is advantage vector critic, kind of like a basic RL algorithm here. We initialize with the supervised language model to give a good starting point for the reinforcement learning. And we also have what they call a KL penalty to penalize the RL model from diverging too much from the initialization. And this prevents the failure mode of the model just collapsing to a single generation that gets really high offensive text. Yeah, so I mean, this is what the results look like if you turn this KL penalty down and let the model really aggressively optimize the reward. Here you get this convergence to this phrase, like if you had to be invisible, what would you do? Because it's able to almost half the time elicit an offensive response. So this is really showing how like we can kind of model adversarial users by doing this RL approach. Yeah, so kind of the different methods that I've shown are kind of on a spectrum of difficulty of the questions they generate in terms of fraction of offensive replies they elicit, and also the diversity of the replies. So here I'm showing some diversity measure over the test cases generated. And interestingly, this like red point here is the bot adversarial dialogue dataset, which is human generated red teaming utterances. And we're kind of along this Pareto frontier of diversity and difficulty to human red teaming, which is really cool. You can do interesting things like cluster the questions to find patterns. Like the model has a lot of favorite things that it shouldn't have favorite things of, for example. And then like with those insights, you can actually come up with mitigations. You can do things like find common noun phrases in the offensive replies. So for example, half of the time when the model says the phrase "this joke," it is saying an offensive joke. And then you can even look at like what joke is it saying. And in this case, this joke occurs like, I think it was something like 200 times in the training corpus. And so then you might want to go back to the training corpus and remove that for the next iteration. Or you might just want to, like, as a quick fix, just blacklist the phrase "this joke" so that it's unlikely to occur in the output. Yeah, you can also do things like red team for data leakage, as I mentioned. So here we use the same set of red teaming questions to from the zero shot approach to generate responses, and then we check, do any of the responses have a 13 gram, like 13 consecutive words in the reply that are also in the training set. And here we find like lots of examples here, like the model is quoting things like verbatim, but also like without attribution. And a very common way to do this is like to get this kind of data leakage is just ask the model for a quote, and it will just give you a quote, which is a very intuitive failure mode, but it also is like leaves the model susceptible. Like if your data set is proprietary, like in the case of OpenAI, say, then this is a very effective way to try to like figure out like what training data did they use. And I think that's kind of like a way of doing intellectual theft, basically, where you could use this to like figure out like what data is being trained on, like when you try to reproduce the model. So I think this is kind of like a way to like find those kinds of attacks. Another thing is red teaming for phone number generation. So here we kind of run the same thing, and we find the model is recommending users to go to the US suicide hotline, or to like call random hospital phone numbers, or to call personal phone numbers. Yeah, so I think I would check out the paper for like lots of other like really interesting like model bloopers effectively, but I think this is a pretty effective way to find quite interesting examples. Yeah, and the last thing I would say is we can also do red teaming for conversational harm, so we can just generate entire dialogues between one language model and another language model and see, you know, how like are there interesting patterns in how offensiveness evolved over the course of conversation, for example. Yeah, so kind of the overall point here is just use language models to uncover when your other models are misaligned with human preferences. They're really good automated tools for figuring out when models are failing to behave in the way that we want. So I think this is something that we can leverage more to get more and more reliability from our models. Yeah, so I think, yeah, with that, I think I'll just kind of close. Like, I think these are the kind of key things that I think we need to continue to focus on. Like I was focusing on the last part of the talk on high quality testing. I think there's still a long way to go. Like there's so many additional methods we can use to further improve the red teaming, to improve the diversity of the inputs that we're giving to do this testing process. I think ideally we just need to get 100% reliability, or like 99.999% reliability, to really ensure that we're not harming users. And like this is the level of reliability that commercial applications need. And I think we're really long way away from that. And especially for like as we're getting more and more powerful systems, we're going to use them in higher and higher stakes settings. Like yeah, I think in the coming decades, we're going to start using them in more places that are going to be replacing like human intellectual labor for like code generation or for like writing factual content, and these are going to be a lot more like high stakes settings compared to where we're using them now. And like in a lot of these settings, like a single failure could be really catastrophic, like dangerous code that's generated, API calls, like crazy trades on the stock market, things like this. Like I think we really need to catch those immediately. And also we need to make sure that we're not incentivizing those with our training objectives. So yeah, I think with that, yeah, happy to take questions, and feel free to email me in general if you have additional thoughts here. Thanks.
Not sure, but if you heard that, but there was a huge applause. Okay, there's some questions. I'll bring the microphone over because our catch box might not have been charged enough yet. Okay. So I think you had a question. Yeah.
Hi, can you hear me?
Yeah.
Great. Thanks for the talk. My question is, it seems to me like these approaches kind of revolve around, you have a data set that contains like some things you don't want the model to do, and then afterwards kind of correcting that through fine tuning. My question is, if you imagine kind of having a sanitized data set that didn't include any offensive language and training a model exclusively on that, would you then have faith that this model wouldn't require this kind of fine tuning? Or do you think there will always be problems that you'll need to correct through this kind of an approach?
So by sanitized model, do you mean a model that's trained on text that doesn't contain certain content?
Yes, exactly.
Yeah. Yeah, I think it's hard to say in advance what the failures will be with some certain approach. Like, I think we can always hypothesize what would fix some failures. But for example, with the sanitized model, it's basically undefined what it does out of distribution. And so if you give it some offensive text, it's not clear if it's learned the generalization, give a non-offensive completion, or complete the text in a similar way as the original text. And if it, for example, like some, I think I showed this response earlier, like, so are you, like that's the kind of generalization that a model could learn if it's trained only on non-offensive text. So I think basically, like, we should try to do things like what you're describing, but I would be pretty skeptical that it would work to the level of reliability that we need, and that there's like not a single bad generalization that we need to train away. And so I think that like kind of does push me towards like, actually the models are like, we do need to do some of this like after the fact fine tuning as well.
Great, thank you.
Another question. Just a sec. Come from that side.
Hi. Do you think by this method, do you clear the language model of the underlying bias that produces that, for example, racist or offensive language, or do you think that it just or do you think that the bias is still there in the model?
Yeah, this is an interesting question. I mean, I guess I would ask, like, if the bias isn't in the output, then does it matter? Because I think, like, to some extent, the output is the only thing we care about. Like, maybe we also want to ensure that the output is going to be good, like, off distribution, and not just when we're testing the model. But I think, like, the ideal scenario is the model has the representation of what good and bad outputs look like, but it only just generates the good outputs. Like, this is what, like, humans who are aligned with human values do, is like, we have very robust representations of what good and evil are, or like good and bad are, and what other people's preferences are. And we specifically choose the good or cooperative action. And like that's like, you know, if you didn't have a good representation of what evil or bad things were, then we'd be much less robustly able to do the good things. So I think that's like, I think if you get both of these components of like a good training objective and really good testing, like if you're really robustly optimizing this objective that is trying to train away the bad behavior, then the ideal case is you just get on all realistic inputs, you get the right output. In which case that's like roughly the situation that's going on, is the model has this like representation of bad outputs, but just never generates it.
Okay. Yeah, thank you. One follow-up. Do you think there is or do you have an idea how that could work? A system to test if the language has learned the concepts of what good and bad, like language and so on is, or?
Yeah, I think these are pretty good. Generating inputs are pretty good ways to do that. I mean, ideally we would have something like good interpretability tools to understand like what computation the model is doing, and if it is doing the right kind of computation to understand some sort of concept. So I think, you know, maybe if you might imagine if we like, I just have the language model as a big box here, but you might imagine that, I think this has happened more in vision, where people are able to pick apart like, how is the model doing dog recognition? Well, it's doing dog recognition because it's first detecting left-facing dogs and then detecting right-facing dogs, and then it does an OR between those two operations and then predicts that there's a dog if one of those is true. And so there you're like, oh, that seems like a reasonable thing to do. But you can also imagine that there's some spurious correlation that the model's picked up on that you can uncover with interpretability by looking at like neurons, for example. So that I think is like one way to test, to like look for whether the models learned the right concepts. So if you're interested in this direction, I'd really recommend Chris Ola's line of work on circuits style interpretability, where they try to like figure out like what operations and like ORs and ANDs is the model doing to come up with different concepts. Yeah, and I think the other way is just to test it behaviorally. So, you know, like I guess how do we test humans for robust understanding of concepts? At least like how do we do this before we had like good neuroscience or tools for examining the brain? Like we often just like ask people just difficult questions or out of distribution questions that get at whether the model has a good understanding of some certain topic. I think that's like partly what we were trying to get at with this red teaming approach of like, can the model in all situations like get the like good generalization? And you can look at like what are the groups of questions on which it fails and get a sense of like, oh, it's actually misunderstanding this concept potentially, or it's not robustly behaving in a good way on this. So maybe it's like missing something in this particular domain.
Okay, thank you very much.
Okay, I think there were some online questions as well. Some people raised their hands. I can just check who that was. So can maybe take one of them.
Totally, maybe Julian?
Hi, sorry if you already explained it, but like I would like to know if you had more details on the RL algorithm for refinements. Like I think it was like your second topic. I thought you skipped.
The RL for the refinements, yeah.
Yeah.
So
like it was not clear how it exactly worked.
Yeah. So basically, yeah, there's like three phases. One is you have a model sample two outputs for a given input, and then you have a human annotator pick which of the two outputs is better. So that's like the first phase. You collect a large data set of these pairwise preference judgments. Then in the second phase, you train what they call a reward model, but it models these like preference judgments from the human annotator, and the way they do that.
But how big is the summaries? Like when you mean summaries, like
yeah, so the summaries can be, I think here there are a maximum of something like 42 words, so roughly like 3 sentences. And the input is a few, it'll be like a Reddit post. So it can be a few paragraphs long.
Okay. Okay. So that's the inputs.
Yes.
And you can continue. Yeah. Sorry.
Yeah. I can go into details on this specific approach. But yeah, I think like that's the specific summarization task that they're doing, is they're looking at like how do we summarize Reddit posts into TLDR, like kind of summaries that people will give at the end of the Reddit post. So yeah, I think once they have this data set of these like articles and pairwise comparisons over model generated summaries, then you can train another model. So you can fine tune some model like GPT-3, but as a classifier. So this model will predict a score, like a reward score, for each like article summary pair. So there'll be like article and summary 1, article and summary 2, and it will predict a score for each of those. And then they will use the 2 scores to predict a probability that one summary is better than the other according to the human judgment. So it's kind of like doing a binary classification essentially in this particular way. And then in the third phase, they just take these reward scores that are kind of like logits to this binary classification. They just take the logit and use that to train another language model with reinforcement learning. So the model will hear like sample a summary, then you give the summary to the reward model along with the article, then you get a score out, and then you use the score to use the score to turn that into a grading update to the model using PPO or some other RL algorithm. And then you update. For example, you might like upweight the probability of that sample if it got high reward, or downweight it if it got low reward. And then you just keep training on this reward signal.
And have you tried with more than like 2 summaries, like comparison? Because you were talking about like you have like an ensemble ranking essentially, but here you're just doing 2 summary comparisons. And have you tried with more?
Yeah, so here you can collect a lot of this data. So just a lot of pairwise summaries. That's how they do it here. You could also like augment this approach potentially to do not like pairwise comparisons, but 3-way comparisons or 10-way comparisons. And I think the way that would, people haven't done this, but the way that would work is you just pass in like, I don't know, like all of these 7 summaries, and then have the human annotator pick which one is the best. And then you run the same approach to predict 7 scores, and then use all the 7 scores as logits to predict the probability of like which one is the best summary, and then you use the scores from there to do the training.
Yeah, it's a lot more clear. Thank you.
Cool.
Okay, maybe one more online question. There is Zainab who has her hand raised, and I think also in the chat there was something. Okay, Zainab, go ahead.
Okay, what I've understood is that we teach the model what is good and what is bad with the help of comparison, right? It compares 2 samples and it decides which one is better. In this way, it kind of learns the value judgment, right?
Yep.
But it does not consciously know what is bad and what is good. So we need to supervise the model again and again with a lot of data sets, right? Can we go to the root of the problem and teach the model what is good and what is bad in a very philosophical way, and we embed this philosophy in the model? I don't know, it sounds very futuristic. Maybe it's not really possible with the tools we have today in artificial intelligence. But I think if we could do this, we could solve a lot of problems in politics and other problems like in social contexts. Because what we do with this model is we're just teaching the model how humans behave, how humans think, right? And most of the problems come from us. So can we make the model better than us? Can it think better than us? Can it make better value judgments than us?
Yeah. I mean, I'm super excited about that direction. I think one thing that's nice about the RL from human feedback approach and this like learning from human feedback is that it can potentially get results that are better than what humans would produce. So what this will incentivize is the model should produce things that humans recognize is good, but that humans couldn't necessarily produce themselves. So you can imagine some, like if you were to use this in like a math setting, people might not be able to prove some crazy math conjecture, but they can recognize a proof to the conjecture if it's given to them. And I think we like that approach can also apply to things like in the philosophy domain, where people might have a very difficult time writing a book on consciousness or moral philosophy, but have a much easier time reading one and recognizing if it's like makes sense or not. And so that's like part of what this RL from human feedback and like learning from human feedback is leveraging, is that sometimes there are behaviors that are really hard for people to do optimally, but they can recognize that. And so this is a way of like extending beyond human ability. So and then I think there's like other approaches that could do this as well. Like this is just kind of one approach, but yeah, I think the general idea I'm very excited about.
Okay, thank you.
Okay, there's another question in the audience. Sorry? I think we have 5 more minutes, officially, if Ethan has the time.
Yeah.
Okay, so could I use the same methods to shape the model to think or produce outputs in worldview I wanted to have? Like, could I also say, I want the world model, the language model to have an racist worldview, and could I use the same methods to gain that?
Yeah. I think these methods are there's certainly like lots of dual use questions around like any of the methods that I presented here, and like we have discussions about that in the paper if you're interested. I think I think like one thing that will be important is there's got to be some trade-off between the model designers and the users in terms of like whose preferences get incorporated, because the model designers and honestly, like, I mean, there's a lot of stakeholders when you have a model generating text. Like the user is just one stakeholder, but there's also the user can do things with the models that have externalities on the whole country or on the company, because the company is like liable for some of the things the model is generating. So I think all of those stakeholders should have some influence on what kind of text the model can generate. And so I think, there's got to be some like balance basically, where the model designers might want to enforce some like hard constraints that the model should never generate anything incorrect or never generate anything like offensive, but then let the model be tailored beyond that to the user preferences. So kind of do the minimal set of important constraints and then let the user guide the behavior. Like it's probably okay if the model is talks in like a conservative way or a liberal way, as long as it's not like breaking some like harder constraint. So I think, anyways, I don't know the exact right decision boundary, but I think that's the sort of thing where I'm excited to get, say, like social scientists and people with other backgrounds, or like policy backgrounds to like figure out like how should we make these trade-offs, given that there are like so many different stakeholders involved with when we are generating text.
Yeah, that sounds like a point where we can actually include them to shape our models. That's actually a great thought. Thank you.
Okay. Maybe one last final question from myself. So right now, you motivated us a lot that we want to use models to shape other models and train other models what's good, right? It seemed a bit like you shift the problem only from the target network to the red classifier network. But at some point, you also say there needs to be a human in the loop in your first part. Like as an open-ended question, like 20, 50 years from now, do you think we still need humans in the loop, or will there always be well-trained models that can teach other new models?
Yeah, I think that's still a question that I'm uncertain. Yeah, I think I have a lot of uncertainty here because like as some of the papers here have been showing, like there are more and more pieces of the process that we can automate. And yeah, I think there's kind of like two possible endpoints. One is like, we just provide like a single sentence describing what we want, and then we hand off all of the supervision process to other models. So the models understand the single sentence, they're able to infer like all of our preference from maybe it's like a paragraph or a document or something, but we just write this once, and then the models actually do the training of other models, they do the testing of other models, they do the correction of the other models. And then I could maybe imagine that this is a bit harder to imagine, but maybe from language model pre-training itself, the models already have some sort of representation of like what it is that people want. And so it's possible that like we might not need that human supervision at all. It's kind of hard to imagine what that would look like, and I don't have a concrete picture there, but it's definitely like a question mark that I have, is that like actually if the models are getting such great representations of text from doing things like next word prediction, all the knowledge is probably in there about like so many different facets of like what sorts of things people do prefer or don't, and there might just be a way to elicit that such that you can train a really aligned system, like maybe even without additional human input, but just from the unsupervised text, basically.
Okay, thanks.
Sorry, I asked a question in the chat. Could I ask it now, or is it too late?
Go ahead, please.
All right. So I was wondering if we are correcting the model this way towards more neutral language, for example. Have you looked into how this affects the answers of the model in general? For example, if I ask for some factual, normal, unoffensive question, will it tend to answer more vaguely after the correction? Because it hasn't really learned to be less offensive, but rather to be less specific or more general in a way.
Yeah, I think the real solution to this is to do it at a large scale, like in an iterated way. So we want to correct the model, and then the new model is going to have some other failures, like maybe the vagueness thing you're hypothesizing, and then we provide feedback that, hey, your response is too vague, and then we correct that. So I think by doing this in an iterative, continuous way, we can continually improve the model. And this is very similar to the approach that Anthropic has been pursuing with the assistant model, where we're like constantly collecting feedback on our latest version of the assistant and getting, I mean, we're doing these like pairwise comparisons, but I think the same general point holds of like, okay, we collect more feedback on the model. Okay, that new model, then we train it. Then this new model has some additional new failures. Then we keep collecting feedback there. So I think this iterative process is really part of where we get a lot of power to like beat out a lot of the different failure modes.
Okay, with that, I would close the very interactive session. Thanks a lot, Ethan. Yeah, I think we will see you already in 50 minutes for the panel discussion. And there we try to keep it for 60 minutes. So also the youth hostel people can get dinner at at around 7 when we try to finish 6:45. Yeah, and now it's a coffee break. So thanks a lot to Ethan again.
Thanks.